Hey, my name is Lincoln Atkinson, and I'm a senior developer on the Visual F# and Managed Languages team. In this video, I'm going to be talking to you a bit about F# and what kind of unique benefits it can bring to your projects. If you haven't used F# before, or maybe you don't know much about it, that's okay. You'll get to see it a little bit today. F# is a functional-first, cross-platform, open source, and enterprise-ready language. It's being used today in startups and large companies all around the world. In Visual Studio 2015 preview, you'll see the beginnings of Visual F# 4.0, which was developed in full partnership with our awesome open source developer community. So what are we going to cover today? Well, we'll take a quick look at some of the major advantages F# brings to the table and try to answer why F#. Then we'll jump right into some code and see F# in action. To wrap it up, I'll point you towards some links and other great F# content so you can learn more. So why should you consider looking at F#? What makes it unique compared to the languages you're already using, like C# or VB? Well, first of all, F# as a language is designed so that your code stays as bug-free as possible as early as possible. This is done by emphasizing functional style programming and patterns. Data is immutable by default, so instead of mutating or changing values of variables, F# code is all about using small, composable functions that work together to transform data. And you'll be happy to know that F# code rarely encounters those dreaded null reference exceptions. Instead, F# uses option types, which make it a requirement to check whether data is present or not. You'll also notice right away that F# syntax is really concise and lightweight. You don't have curly braces or semicolons or begin sub, end sub all over the place. You just have meaningful code. And you don't need to explicitly list the types of so many variables and parameters. The F# compiler uses powerful type inference to figure this out for you most of the time. Well, this all sounds nice, but my company's systems are already built on C# frameworks. No problem. F# works with your C# code, and vice versa. Since F# compiles to .NET, just like C#, compatibility is seamless. F# works with other managed frameworks and libraries, and of course it supports pinvoke too. Okay, so let's take a look at some of this in action. Here's a simple F# and XAML WPF app. The app is pretty straightforward. What you can do is load up an image, and you can drag this little rectangle around and resize it so that you can capture these little champions as a cropped image. Save that off and make sure it looks the way we want. There we go. So what does the code for this look like? Well, I have 3 files, starting with app.fs. That's the main entry point into the program. There's not too much going on here. It's mostly just hooking up event handlers. One thing you'll notice is this distinctive forward pipe operator. You'll see this in a lot of F# code. It really emphasizes how your data flows from one function to another. Most of the interesting stuff is in windowActions.fs. We have a few modules in here, first one being image file dialog. So these classic Windows dialogs for opening and saving files, well, those don't always return data back to you. If the user clicks cancel, for example, no data comes back. So in C#, maybe you would return a null string for that. In F#, we try to be more type safe about it. So what I've done is I've had this explicitly return either some with the file name or none. Later on, the code has to handle these 2 cases or it won't work. Most of the callbacks are defined in window actions, including this main type that represents our app, main window. This comes from the XAML type provider. The XAML type provider is an open source project that's really great, and it leverages the F# feature called type providers, which allows you to bring in data from pretty much any source and represent it in a strongly typed way in your code, all without the help of anything besides the compiler. No Visual Studio designers, no tools. It's all there in your code. So a lot of this is pretty straightforward stuff. Let's go down to a part that really showcases F#. So when the user clicks on that red rectangle, we either want to drag the rectangle if they've clicked inside, or if they've clicked on the bottom right corner, we want to resize the rectangle. So there are really three cases when you click. Either you're in the bottom right, and we are resizing, you're inside of the rectangle, and now you're moving it, or you're outside of the rectangle. So F# makes it really easy to keep your business logic super neat and tidy. You just have these three cases. It's really clear what the code's doing. So how do you implement something like this? Well, you can define what's called an active pattern. This is a really neat F# feature. So we can put all of the messy business logic here. We say that there are three cases: outside, inside, or bottom right. The inputs to this are the main window and the point where the user clicked. So we get the information about where the rectangle is now, do a little bit of calculation, and then all we need to know is, are we in the region, near the bottom, or near the right side? And we can detect which case we are. And in case we're inside, we want to keep track of the offset from the corner. So this works really well, and when you debug your code, say we click inside, you step through this, and there you are in the inside case, and you have the offset of the pixel that I clicked on. So I won't show you too much about the image processing. It just wraps up two bitmap types, the normal Windows desktop type and the WPF bitmap type. But look how short and concise these F# type definitions are. No boilerplate. One last thing that I want to show you is that F# has an interactive REPL. So you don't always have to be recompiling your project and rerunning your app. If you want to run small pieces of F# code, you can do that right here in F# Interactive. So let's load up a couple of references. This has loaded up some DLLs, and it's also loaded directly the source from our app. So we can now access anything that was defined in image.fs. We open a couple of namespaces, and maybe we want to test or just verify that our image loading code works. So if I do image.load on a file, there we go. We've got all this information about the image right here in F# Interactive. And we can assign it to a variable, and I can interact with it right here. There we go. So it looks like it's working. Wouldn't it be cool, though, if I could actually see the image instead of just working with this text interface? Well, F# Interactive lets you hook that up as well. You can add a custom printer, which we're going to have display a little form with the image in it. So maybe I want to show this guy again right here. There's a few more kitties for you. And if I want to test the cropping, just run that through Interactive. It pops up, and it looks like everything's working. Hopefully this gives you a taste of what F# has to offer, although there's a ton more I didn't have time to show you today. If you'd like to learn more, check out some of these pages, including the online hub for F# activity, the F# Software Foundation, the Visual F# Team open source repo on Codeplex, a really great learning resource for anyone looking to get started with F#, and an excellent Visual Studio extension for F#, the Visual F# Power Tools, which enables many of the handy IDE features that you're used to from C#. Thanks a lot.